Hi ma'am, can you hear me?
Yes, sir.
Yeah,
Yes, sir, audible.
Sir?
yeah, I can hear you.
Yes, sir. Can share the screen, sir.
I'm sharing it. Can you see my screen?
Yes, sir. Good morning, everyone. Today we are going to have a
This meeting is
section
being
of
recorded.
flow designed for data science, presented by our resource person, Aksam Mohammed. He is a senior data scientist from Securin. So he is going to give us a detailed flow about the data science and also the new technique called Kubeflow, which is used for our ML techniques. Sir, yeah, the session is yours, sir. You can start.
Uh, sure ma'am. Let me start with the things. Meanwhile, if someone wants to ask questions or because I am not able to see any screen, anything, you please intimate me in between. Meanwhile, telling about myself, I am Mohammad Aksam BK, senior data scientist from Securin, and uh, telling about Securin is a cybersecurity company which deals with IoT, uh, the other software related cybersecurity works, and what exactly we do is like we actively do pen testings and as well as vulnerability management. So regarding myself, I did PhD in mathematics, and I have been in data science for around more than 5 years, and I have seen biological data analysis, further retail data analysis, and cybersecurity currently, those data, and as well as gaming technology data and all. So specifically on today's talk is about cube flow design for data science. This title is a little bit advanced concept than just a basic data science concept and machine learning. Why it is this tool is very much interesting and it is used in industrial applications are it helps to maintain our end-to-end machine learning pipeline, as well as it can able to communicate with several instances, worker nodes or clusters of computers, and it will help us to do machine learning on top of it, and it accumulates the data, and it gives to the final node, so as we can see the results. One of the biggest challenge in machine learning nowadays is we are looking forward for some of the tools which can simplify most of these concepts, because what happen in real life situation is we get a huge pile up of data. Sometimes we get active data, sometimes we will be getting passive log files or some of those data points which is in our system. The problem what we are facing here is we will be having a massive amount of data or some chunks of data. Also we are having some of the issues with latest trends and technologies and latest algorithms which are all coming up with. Now we want to see that while in production, while our application is live and our client are using it, at that point of time what we are having in issues are, we want to switch to different ML algorithms, and we want to check how that latest technology, latest algorithms are performing than our previous algorithms. Now if we want to just like that switch to a new ML algorithm, we should be having some certain tools that we want to disconnect that ML algorithm tool, and we want to connect with a new ML algorithm, and we want to see how much improvement that specific algorithm is giving, how much specifically the new algorithm is performing than the previous one. So to orchestrate our ML algorithm, we need uh, we need a collection of tools. Rather than going to the collection of tools, we can go with this Kubeflow specific tool which can help us to go on. And this is not nowadays the things are not specific to data, or this is not confined to a specific field of computer science, as we see as in electrics and electronics, new FPGA, or even like IoT devices or Raspberry Pis and other new technological devices which are all industrial control systems, in even in chip optimizing technologies and all. In all these technologies, we want this machine learning algorithms or deep learning algorithms are actively helping it to improve our accuracy of that specific tools. Now if we are discussing about those specific uh, device or technologies to be optimized, then their inner code should be maintained in such a way that we can switch to different algorithms just like that, and we want to see what is the accuracy of it. The problem is, like, if we don't manage all this orchestration in a very well manner, then we will be having a lot of issues in maintaining it, safeguarding by security means, and integrating with other tools. As you know that now our mobiles are integrated with our internal home systems. You know that we can get pulsatile data from windmill which is far away. Even 50 or 100 windmills are sending pulsatile information that they are actively producing the electricity to the remote servers. So all of this, even food processing unit, or even like automation of car making, all those devices, all those things, and all internally we are started using ML algorithm. We are using in such a way that these are all a black box to us, but still we are moving ahead to use that and bring lot of this technology to the other field, in medical field, other industrial fields and engineering applications. So the basic agenda for me is, as I know that this is a complex and little bit advanced topic, I want you to start with the basic machine learning infrastructure in cloud, and follow with what are all the data science workflows are there, how we in industry we are handling it. Of course this might be little bit overhead to you, or it might be advanced to you, but these are all some of the outlines. Even after my talk, if you individually search for each of these component and how exactly we are making an application by using machine learning algorithm, you may able to understand each and every component and their use cases. So bear with me on this. I will be touching on the basic concepts to in-depth machine learning implementation, and I will go through very slowly to explain you what are all the concepts of machine learning, what are all the concepts of data science, what are all the concepts of software engineering, because all of these are playing vital role in maintaining huge pile up of the code, and how we are integrating sensibly to come up to that speed. So my agenda is like basic machine learning infrastructure in cloud and data science workflow, followed with containerizing, why we want to containerize our application, and how we want to use each of these container in the form of one building blocks to build our overall application, followed with how we can scale it. As you can see nowadays in latest technology, for instance, like I used to give always whenever I give an example to containerization, I will give an example of Flipkart. Suddenly on big billion days we have a huge customer base coming up to us, and coming up to the website, and they need a lots and lots of work hours of servers to be utilized. So as everyone wants to buy the products on those festival or those big billion day of Flipkart or Amazon or whatever it may be. Now making those count of servers available every day is useless. But if you are not making that much of server available on that specific day, then you cannot able to earn a lot of money on that day. So what exactly they do is they replica the exact container in to similar lots of similar lots of server. uh, all of them are cloud based server, and they replicate it and make it available up to when we need it, for 1 day, for 2 day, for 3 days. After those 3 days, we are just deleting, we are just removing all those server from the cloud. So this is one of the example of scalable machine learning, and how to scale it and how to descale it by using specific Amazon based AWS cloud. Now we are having Google cloud or even IBM cloud or several clouds, but I want to give one specific example of Amazon, so as you guys can able to understand and visualize how it is implemented right there. And if you are able to understand in one Amazon cloud, then replicating in other Google cloud and other services like Microsoft Azure and all, it will be easy for you. And also please you see on the other two aspect of it. If uh, Kubeflow is not only specifically to build machine learning algorithm, it is helpful in building applications bit by bit in a proper structured way. uh, uh, we want to utilize its capability in data science and machine learning, because we are building a application by using this machine learning and all. That's what the base idea. And even if you understand the cloud concept, even you understand a bit of data science and machine learning, that will be helpful for you to explain it in interview. Like these are all the concepts of cloud, these concepts of data science and machine learning, and how we want to implement in a specific industrial control system or IoT or Jetson Nano or Raspberry Pi. I still use this Jetson Nano based cloud Docker based implementation on most of the applications of Jetson Nano, because one of the application of it is you can see that these devices are individually can able to maintain some of the tools. Assume that in windmill scenario, 4 windmill will be connected to one Jetson Nano, the NVIDIA Jetson Nano or small Raspberry Pi, to give actively pulsatile effect, or how it is processing the electricity actively, whether it is active or not. Those information it is accumulating and it is sending it to the mine server. So individually we can replicate the similar thing what it is happening in one system into several systems by using image based system, which is called building an image and Docker images and all. Let me move on machine learning infrastructure in cloud. As you know that we have been while in college, you can see that uh, we are building machine learning algorithms end to end in our local computer or PC or laptop. Rather, why we need cloud and what is the exact need of cloud in industry? Now, if data is a huge data and we are having a big applications, for instance, you have seen this chat gpt and other applications, you cannot hold it in your computer, all of that pre-learned model in your system itself. You need a massive data storage and massive cloud to process it and to answer you. So they will give you only the front end UI or from web page kind of view. You will be typing something to get to know from chat gpt, but what is the exact processing it is happening in their cloud? That's what the exact thing which we are talking about. Now this machine learning infrastructure is offered by some of the clouds. What they do is they give a big virtual machine to you or computing power to you, where you can build your own end-to-end machine learning application. But rather that is not practically feasible solution, because you guys are doing the same thing, or most of the customers of Amazon cloud are using similar applications, or some of the 5 algorithms and all. So they thought that they can come up with some of the ready-made auto ML tool, which on switch of a on switching some of the specific ML model, you can get the results to it. So this is what it happens in specific ML auto ML services, which is offered by Amazon and other cloud services. So they have categorized these services into vision, speech, language, and some of the basic auto ML models into ready-made applications or ready-made tools, which you can use with your data, and you no need to write from a scratch Python code in and out to get the results. So you can be just a developer. You may not need to be a machine learning expert. Assume that you are a electrical engineering guy, you want to perform some of the analysis, machine learning analysis. You should not be having that much in-depth knowledge of machine learning and deep learning. Rather, you use this ready-made auto ML, means automatically you can deploy some machine learning algorithm on top of your data and you get a solution to it. This will be offered as services to you. So this is very easy, anyone can try to do that. But when it comes to the platform, while you are training your own model, fine tuning your own model, serving your own model, you should have the skill of machine learning and data science. So as a data scientist will help us to write raw code to develop, to train, to fine tune the models and to get the prediction out of it. So your easiness will go from up to down. Here everything will be controlled with, and not only this training, tuning and serving is based on data scientists. There exist this CPU, GPU instances, or cloud instances, or even the cloud platforms and all. Those infrastructure will be utilized based on as a service. For instance, like you need Amazon cloud for 2 days, you will pay for only for 2 days, and you just switch off the cloud and you will be billed only for whole 2 days which you are utilizing it. Now to maintain this CPU and GPU in your local or in your system, rather you can use the cloud services who offer you for 1 or 2 days to do your POC or to do your analysis for short period of time, and if it is working, then you can think of a big thing. So a sample run and all will be ever utilized with automated infrastructure provided by these cloud companies. But of course this will be charged with the amount the service they offer. They will ask for that much of money from you. So but as you know that big organizations cannot handle most of this training, tuning and serving, just like you doing on one research paper or research project, or you can handle in your system. But if it is a large amount of data, around 5,000 to 6,000 customers data and all, it will be a huge amount of data which you cannot able to handle just like that. So we are looking forward for this kind of cloud infrastructures to help you out with some of the ready-made tools to carry out those process. But it will ease you in such a way that it will help us to. But they build themselves lot of these application, and even lot of computer scientists or programmers are working behind to build these applications. For instance, this machine learning becoming a significant workload, public cloud providers are investing in core infrastructure, building platforms, building services to attract enterprise customers. So they are building those applications, and again those students or those skilled programmers are still used. Skilled programmers will help us to build all these applications or services. Rather not only the services and tools, as you know that even hardwares like GPU, TPU, FPGAs, all of these are hardwares on which on top of it the software runs, and you have to also understand what kind of applications and what kind of scenarios are there to build those softwares on these specific tools. So moving further, this is the exact data science workflow. Okay, I am having, assuming that I am having several Python code here and there that I want to run one by one, assuming that first I want to load the data. So I have renamed the file as load data.python py. Run this Python file, and what is the result we are getting from here? It should go to pre-process file, then this, and then this one. Like I want to check on 3 different machine learning algorithms how it is giving the results, followed with evaluating my model, followed with if it is giving a good result, then I want to deploy this algorithm. Now each one of these Python code is hanging here and there. Now I want to organize it, and I want to structure it to run in my industrial environment. So this is the exact Kubeflow tool for which I am looking for. What it exactly does is each of this file or Python code, it will convert into one container, and each of these container will run based on one after other or based on the condition. Each specifically we will be getting different results, and intermediary data we have to pass over, and we have to store intermediary data, if we need it in some of the volume of volume if you give, or memory space if you give, it will store intermediary files if you need it, or otherwise you want to run a sequence of code, uh, to organize it, we want to go with the Kubeflow. So that's where the Kubeflow is an orchestration tool or pipeline tool or whatever you can say, but it is not only containerizing it, rather it will be able to organize it, it will be able to help if some of the components are not working. So we will be discussing thoroughly how this tool works and how this tool orchestrates to get our results. Cool. So this is what the introduction of containerization. Now the first question is like, why we need a container and containerized based implementation. First and foremost thing why we need container based implementation is to manage our code along with uh, assume that 10 years to 10 to 12 years old code and all, it is not a containerized one, rather it is a raw Python code, raw C code, raw C++ code. So right sizing the space needed for it, or to maintain those specific projects along with their specific codes and continuously updating it. You see that different version of new codes are coming up and all, there we will be finding a lot of difficulties, where this specific tool will be helping it out. Further, you can design in such a way that you can see in this pictorial representation itself that how I want to design and how my code flow should go on. So you can start by designing, developing and deploying it, managing secure application, not only in your local, private and hybrid cloud. Assume that some of the organizations are looking forward for multiple cloud environment due to several reasons. They are having both Amazon as well as Google cloud. Now that it means then it is a hybrid cloud, where you have to do some of the process in this cloud and some of the process in that cloud. So the thing is that as a developer, assuming me myself as a developer, I write some of the code in my local. The same code I want to send it to big cloud. It should munch huge amount of data. I am doing a sample analysis in my code and I am deploying it into the cloud. So this physical cloud, virtual cloud, anywhere or any OS, assuming that I am having Windows OS and cloud is based on Linux, all these things uh, are a pitfall, or all of these are creating a lots of problems in developing several codes. As you know that in real industry situation, there might be 50 to 60 peoples are actively working on 60 different concepts or sub concepts. Now each one of them can have a different platform, different OS and all. Now if we are collecting all this code and we want to make it as a overall application, we find a lot of gaps and lot of issues in building those things. So what this containerization will help us to arrange it. As you have seen, what is this container concept comes in logistic. You see in ships and in train and all, there will be lot of containers. It will be in a this size, like rectangular size of this much and this much. Why we want to maintain is, we know that a container space is given to one shipper who can fill all those things inside it, and all the containers can be properly sequentially it can be maintained. So that's the same way, the same concept it has been developed. and it is not the new thing what we are talking right now. The first containerization came in 2013, a decade ago, 10 years ago, with the release of a Docker, and after that it has been continuously improving itself. One of the specific thing which we have to look on is all the cloud based implementation, Amazon and Google Cloud, IBM and all, everyone are following cloud based implementation, because if lots and lots of clouds or lots and lots of codes are accumulated, they are finding difficulty to manage. So they are this cloud people are thoroughly following this containerization concepts. We have to understand, if we are moving to cloud, we have to learn these concepts and all. Otherwise we have to build from a scratch, and we have to use bare metal or raw environment, and we have to build our application from a scratch, and it will be like much more issue than just organizing it by using Kubernetes or other cloud based implementation. Cool. So in 2019 it was only 20% of organizations are using this containerization concept, but in 2023 it is almost 70% of the peoples are utilizing it. Then it means that within some of the year might be all or 99% of the people will be started using it, and that's what we have to have these skills, and we have to utilize this technological concepts to move advance in this field. Now, why to use containerization? As I have been discussed thoroughly, like some of the memory and spaces which is underutilized and overutilized. Sometimes like we don't know when our server will crash. You have you have uploaded huge pile up of data and code and sequence of code, and we don't know when it will be crashing it. So there is a monitoring system needed, which will help us in showing server utilization and monitoring those things. That's what the thing which we are looking for. And not only that, if we are allocating the space, the code, the data to specific containers and all, we can able to reduce the maintenance cost, and lot of people's and confusion will be reduced. So that's what the provisioning cost they are telling. Further, performance, obviously, if you make it simple, the performance will automatically increase. Portability, you can work in any environment. It doesn't mean you have to work in Linux, you have to work in Mac OS and all. So containerization is irrespective, and it can be easily portable to any kind of operating systems. And complex and time consuming, it will help you out in maintaining time and scalability. If you want to continuously uh, assuming that your website or your software is uh, giving services to more number of people, you can start leveraging more cloud instances just like that, and you can scale it up. And easy to like some of the containers can work in one cloud, and some of the containers can work in one other cloud. So multiple platform and multiple cloud also we can use, and we can do lot of automation. Those things we can do. Still there are some of the challenges in this containerization, like security. We have to look forward, difficult to manage if it is having thousands of containers. So I am coming to the solution for this. To maintaining thousands of containers, we have one graphical method to to make a graph and to give a path one after other, how sequentially we can look and orchestrate or run our code sequentially by using graph tools, DAG, directed cyclic graphs. Further, migrating old code. Assume that some old codes are there, some 15 to 20 years old, like post office code or any other code which have been running for several years. Now we want to convert into this containerization. It will be very difficult, and we have to rewrite the code from scratch. And sometimes we don't know specific scenarios, like how much container we use. We may underutilize, and we may think that how much the space we have to be allocated for that. We may not have an idea, or drastically changing those things and all, it will be difficult to manage. Further, this how exactly this container is created and how we want to do it. I will give one simple example, a kind of hello world to Docker, and Docker are containers. So I will also explain what is Docker and what is container and what is the Kubernetes. This is one or the other among themselves, but each one of them is having a little bit more meaningful thing to it. I will try to explain that. The first and foremost thing is there will be a Docker file which build an image, and that image is run as a container. So this is the three concepts are there which we want to see. Now Docker file can be a configuration coding file which will accumulate further codes, and it will convert into image file. Now you have seen in Java or jar application file. Just with that example I can explain it. You will write some code in Java and you want to make into a jar file and you want to run it. So you will convert your Java code into a application jar file and you run it. Similarly, this Docker file is also like that. You are accumulating in a Docker file the pile up of code, and then you make it as an image and you are running that container. So let us start with a hello world in Docker. Assume that this is the 2-line code of a Docker file. I will give one more example as well, but let us start with this. So from Alpine, this is a command echo as hello world. So you see this Alpine is a base image or base library which is used to run it. Further, like we print hello world on the terminal. Now this is the exact code, and this is a Docker file, and we use in CMD, or we use in terminal to run Docker build my application with version 1. This is build command, tagging it. This is the repository where it should be, and version control. So when you run this single line, it will create a image in a repository my app, and when you run this Docker, it will run and it will give a hello world to it. That's the simple concept it does. Rather than running the Python code by using Python space python.py, we are making this as a Docker and we are running it in our local. Just as simple like that. Further, you can see these are all the commands are there, like build image. You want to list the what are all the images are there. You want to run it in some specific space with those networking elements. You want to push it and you want to pull it. Now I am using ML algorithm, ML model, by using one of the example of prediction in machine learning. So this is the Docker file I created. Now you know that there is one Python file which I want to convert it into a Docker. Docker will have its own OS and it will run that application and it will generate the results for you. Now I want to run Python, so I am using from, which is nothing but a base Python image for Docker, and working directory I have given here, followed with I want to copy local machine to container, this all the data which is there in this working directory. And you know that there exist some of the packages we need in Python. Usually we may need uh, specific Python libraries or pip updates. um, so you can use pip to install some of the packages in the container itself. So and also in the requirement also, if you keep some of the data or list of packages, that will be installed while running or while bringing your container up automatically. So this is the final code where there is one Python file which we want to run by using Python uh, image file. So this is one of the simple example of one machine learning prediction tool which we build by using Docker. So simple, like if you look at the last line, it runs Python code in this on the Python file right here, and it will fetch for some question, or it will fetch for some features, and it will predict for you in Docker. Now this is a Docker file which I was talking about. After making this file or saving this file, if you run by using build command and then run command, if you build it, this is the exact prediction of that Python file that we want to use it in our Docker. So what it exactly does, you can see Docker build, this is tag build command, this is the repository which we talk, and this is the version 1. So we can have several versions, so as we can maintain it with a different series of code. So you see how Docker builds. Very interestingly, it is clearly given in the command line itself. In step 1, it runs from Python, it tries to fetch that image file. In step 2, it is trying to get setting up working directory. It is copying the local cache files. It runs pip install. So you can clearly see in each of this line that which of the line it got run, whether it is having issue, whether it is making that file, and which unique ID it is creating a cache for that. It means that successfully built and successfully tagged to Titanic underscore model with version 1. So one of the best part of this building Docker is like it is continuously telling like where are we and how it is individually step by step it has built. Now you have built this specific model, and you can run it. Docker run -it name this Titanic survivor Titanic underscore model. Now if you run this, you can able to get this data and you can get the results. Rather than running the raw Python file, we are making a Docker and we are running it. The only thing is, if we are having several applications to integrate, this individual Docker files may add as a container, and it will help us to accumulate, or it will help us to organize all these piece of data into one integration tool, and it will help us out. With this simple example, you can able to understand what is the raw Python file and what is the containerization or dockering. By using Docker, we are converting it into container and then we are running that. Now that is a base Docker concept. So rather than a single Python file, you convert into Docker and you ran it. But as you know that things are not so easy in the complex world. There will be a huge application, huge pieces of code available in industries. So managing large number of containers are difficult. So Google came up with one tool called Kubernetes. What Google and Google make it as an open source, so as everyone can use it. So you can also try in your local, if you have a free cloud based implementation, you can try this. So it is not the only tool which Google make. Google or some other organization also come up with several maintenance of these Docker or containers. One of the examples of those tools are Marathon, Nomad, Docker Swarm, Kubernetes and all. There are several containerization tools available, but we are talking about Kubernetes because it was made by Google. They have made it in a very good way, so as not only they are maintaining the data, not only they are maintaining the code, they can run some of the code in some of their worker environment. Assume that you are having 5 different PC in your lab. You take one PC to managing the resource and getting the results and accumulate and show, and all other 4 computers can act as the worker node for you. So this is the cluster of computers in which if you want to run a specific containers in one of the computers in your lab, you can able to give those tasks to the worker node and get it done and accumulate it. So what exactly it happens in cloud is you will get one instances. You can get 5 or 6 instance, and you can form a cluster of nodes, and then you can use Kubernetes tool to maintain these results. Now you are able to understand that Docker is a concept in which you convert Python into the container and you are just running it. But Kubernetes is the tool which is having much more application of maintaining this overall code end to end, not only in a single computer but multiple nodes of computer, and accumulating the data and monitoring it, maintaining it and all. So we will be discussing about this specific tool, and this is the part of Kubeflow which we are talking about. Kubernetes is the half of Kube, and instead of netis we are telling that flow means a flow of diagram or graphical representation of one after other what we are getting it. So our results, we are slowly moving towards Kubeflow. That's what I mean to say. We will see what is Kubernetes and explain what Kubernetes is not, relate Kubernetes concept, describe capabilities of it, and what is this ecosystem. It is not just a tool, instead this is called as a ecosystem. Now why we are calling this as a ecosystem? Now if you are making a Docker as a separate environment, virtual environment, then you need to give some space, memory space to it, and you need to give all that monitoring things and lot of other tools and all. So if you are orchestrating all of this, then only we will call this concept as a ecosystem rather than just a tool. Tool will do one concept execution, rather ecosystem will have a several concept accumulation in the ecosystem. So I was not talking about worker nodes and all in Docker, but I am talking here in Kubernetes because we are having those concepts only in Kubernetes and further advancement. Like there are pods, or there are smallest deployable compute object. In Kubernetes, one compute concept is called pod, and several concepts are accumulated and called as workload, and as simply we can see, and there is services, storage. For each of the pod you have to give one store of data, or access to the storage, so as it will fetch the data and it will calculate something and it will give it to you, and you have to give configuration and security. So all of this concept I can show you visually. Before going to that, what are all the other concepts which Kubernetes is having capabilities of? It can roll out or roll back. Assume that something wrong had happened, it will go back to the we can go back to the previous iteration. We can do that, and progressively, like you can roll back, change, and all things you can maintain. A kind of like uh, GitHub and other code commit. Other thing is storage orchestration. You can embed some volume of data, some volume of storage. Either it may be a cloud S3, Amazon S3 data space, or even your local computer space. You can glue it to the Kubernetes, and you can do horizontal scaling. Now, what is horizontal scaling? Means I am having one or two pod. Similarly, with same configuration, I can scale. I can make two more replica of it. So making two more replica of it, I can have a good strength of compute power if it is needed. And when we don't have that much of load, it will automatically uninstall, and it will leave the two more node or two more computer. So it can dynamically maintain horizontal scaling. Not only that, it is like it will automate bin packing, and it will maintain secrets, configuration management, and all. Kind of like who can have access to some of the code, who cannot have access to run some of the codes. All that level of analysis you can do, and you can maintain credentials, keys, tokens, and all nowadays. You can do batch execution. Assume that I want to run first batch of 20 elements, and then 20 more compute. I want to do it after completing this 20. So batch execution can be done. It can self heal it. Assume that some of the code is having some issue. It will restart the Kubernetes, and it will replace with the working code which was previously running. So it will also, if it is run for a long time and it is not producing the results, it will kill and filing. It will kill those containers, and it will maintain self-healing concepts. It will do load balancing for you. If it is if your server is utilizing lot of space and compute power, and it will balance the load into some other worker node if it is having empty or they are not working on that place. And it is designed for extensibility. You can design it and you can optimizely use your code. This is the exact Kubernetes ecosystem which we are talking about. Now, if Kubernetes is not a tool, it is an ecosystem, then it means it should maintain the cloud, open source frameworks, any of the tools it can use. It can have some management tools. It can use different coding technologies, for instance, Java and other things. It is monitoring and logging tools, security tools, load balancing tools. Now, inside the Kubernetes itself, there are some of the sub part of the concept. Each of them are having individual roles to perform. To maintain our end-to-end code in application, we are just organizing and we are monitoring it. We are seeing it. What are all those issues? separately we can log and monitor and see that I want to see one container which is not working in a good way, or it is not working in similar way what I am expecting. I can go to this monitoring tool and I can see that, oh, what is happening right there. Is it one or two Docker is not filing? Everything we can monitor. So there is a specific tool for it. I will show some of the pictorial representation to explain like how it is. So in software deployment, we can see that there are lots. This is the least of things uh, this Kubernetes does: automatic self-healing, load balancing, secret management, automated rollout and rollbacks, storage orchestration. Your storage data will be orchestrated, automatic bin packing, set of workers of nodes it maintains. These nodes primarily host pods which essentially running containers. Each of the node will run several containers in it, and some of the nodes management and control plane which will be responsible for managing it and accumulating the data, everything it does. So it is having 9 of these capabilities. So we want to study more about this. So let me explain it in a very simple way, like what exactly this Kubernetes cluster is. Your main computer is nothing but a control plane. It doesn't do any job. You cannot see any application pod running on it. Means this main system is acting as a control plane, and worker nodes are these people who get a piece of code or the list of tasks, and it is allotted to the worker node, and it generates it runs that code separately, and it will accumulate in this control plane, and control plane will give the results. So there will be a lot of concepts here. Node means more than one physical or virtual machine. Pod is the smallest unit of Kubernetes. There will be service IP addresses for each pod so as to communicate among themselves, and there will be a config file, and there will be ingress additional layers, secrets, and the volume means you are giving some storage space to each one of the applications and application pod. So this is the basic application. Now how we want to bring it into the machine learning concept. Now I am having one data, I want to pre-process it, and I want to run in 3 algorithms: logistic regression, decision tree, and SVM, and I want to evaluate it, select the best model, and deploy that model. This is the series of things I want to do in machine learning, and this is not this is a simple pipeline in machine learning. Everyone does that. Either it is a image data, either it is NLP data, or any data. So you know that these two concepts is like linear one, but here it comes with several algorithms, not only 3, and each of this will be a separate Python function or Python code available. So each of this once these two process is done, the same data will go to all the 3 algorithms. It will find the results and it will calculate it and deploy it. Now these 3 are individual concepts, and these 3 can be done in 3 different node or 3 different worker nodes or 3 different computers. So if you give this task to Kubernetes, it will try to accomplish this result and load balance it. It will send the worker node the code and the data, and it will maintain it. So that's what it does. So it means it will automate it, it will reuse it. Assume that my all these 3 algorithm doesn't work well. I want to come up with 4th algorithm. Then this is an individual concept, and this is individual concept. Means individual container, this is individual container. I will take these 2 containers, I will remove all these these containers, and I will add a new container, and I will run up to end, which means that it will reuse, and we should not write thousands of line code change in each of the Python code. Rather, we are making each of the 1,000 line of code into different concept or containers. Repeatability can be done, and we can decouple with different environments. Now, this is the concept of Kubeflow. What exactly this tool or Kubeflow does is, it will make that same concept into the pipeline flow. Like after pre-processing it, I need to send that data to training data, and after training data I want to predict it. I have some of the validation data which I want to pre-process it, and I want to send directly to the test data, and I deploy the model. So this is the flow. This is the series of concept I want to do. After pre-processing I want to do training, after training I want to do testing, and after testing I want to deploy it, or I want to directly deploy after training it. So I am making one graph, and each of these box is a Python code with a container. So as I can remove or add some of the containers. So all these things I will double click on. I can double click on one of the box, and I will write the Python code of it. I can change some of the things on this. So this is what the Kubernetes concept does. It can able to orchestrate lots and lots of data by using a graph concept. Further, you can see that not only the normal Python training test ML code, we can use deep learning PyTorch packages, and you can see that input data, pre-process and transform, train, marpusher, and develop, deployer, prediction, explanation. We want to push the training data to TensorBoard to see how exactly our data looks like, and we want to build several parallel process also. Once this is tick mark, then it means that without any error this box is running fine as a container. So we can able to build this, and we can able to deploy this. With this I am almost going towards to how we are doing this in this Amazon cloud, and how we want to see, can we implement all of these concepts in Amazon or Google Cloud. Now you can see this is a complex real life application blueprint in Amazon, which shows that how they are able to maintain in industry the several pieces of data. Here Amazon is having several of its tools and concepts other than this other than this Kubernetes. For instance, this is the our control plane, and from this control plane of Kubeflow, several instances are connected to it. But you know that if you are running some data in your local, you will be having an Excel sheet or Excel file which you want to upload into Python, and you want to run the results. But in real application it will not be. In real application we will be having Amazon RDS, a MySQL DB, a separate entity, a separate component where all the data are stored. I want to fetch from Amazon RDS MySQL database to write a query and fetch that data to the Kubernetes container, and I want to run all these concepts based on that. So what I mean by what I mean by this scaling the machine learning into the Amazon cloud is, Amazon cloud AWS is having several of its concepts. You know that final results, if you want to generate a graph, you want to save that data into a artifact results, which Amazon is having one of the place or space or memory space where you can save your results, which is nothing but Amazon S3 AWS secret manager. So they have built a individual component based applications based on Amazon. So all these tools are having individual easy to use ready made applications, so which does the similar concept of one of the concept of a Kubeflow. Either we can use this concept of Amazon and we can utilize it, or either we can use Kubeflow's own component. Now if we are building in a small scale in our local all this Kubeflow application, then we will use this MinIO and our own SQL DB and all this, because it is a very small data and we can able to generate and run our end-to-end results. Once we are moving it into cloud and we want to run our results on big container or big Amazon cloud of overall organization with hundreds and thousands of customers, we can start utilizing each of these concepts, but we have to relate which concept is related to Kubernetes concepts. Once you relate it, it will be easy for you to access and you go on. Now even if you are a developer, even if you are a raw coder, or even you are some of the concepts which you want to use in your machine learning pipeline or in machine learning things, you can utilize individual elements and you can utilize in the cloud. Your data analysis can be done and you can move ahead. So that's the way Amazon and Google Cloud are built on. So this is the final slide I want to go on with Kubernetes, with Kubeflow, with Amazon AWS. Further, there are a lot of books which you can read, which is related to data science and practical statistics for you to go on while using your data analysis. And the thing is that you no need to read each and every book, each and every page of it. If you are working with time series data, you can take that data and you can do that statistical analysis with some of the example concepts of it and you can move ahead. You no need to go through the overall library. Just like Wikipedia, you are searching for some specific thing which you want to learn and you want to deliver it. So for your concept, you have to understand which are all the concepts we have to understand. That only very few concepts, if you are able to learn it, you can learn and you can go. And not only here, even in Amazon and cloud based implementation also, you can able to go through thoroughly analysis of some specific tools and packages available. What is the input of it, what is the output of it, how to use it. That concepts only will help us to build your ML model and get the results. Once you are not happy with that example, go with some more examples and see it. So these are all some of the references and codes. If you are interested, get this PPT and go through it in a very slower manner to see what are all these concepts and how this Kubernetes is set up. It is not an easy concept to set up Kubernetes cluster, because it involves multiple computers to set up this. Even you can set up in one single system, which is called mini cube, like mini or lighter version of it. And there is a hard way, or Kubernetes hard way, in which you can able to set up end to end with videos available in YouTube. You can able to set up this Kubernetes and you can practice it. Nowadays it is very easy for you to practice it, and even Amazon and Google Cloud is giving uh, some credits free, so as you can practice and you can learn it. And if your company, if you are joining in a company, they are giving you a cloud, you can able to access it. This is my organization, my team member here, and we are building some of the products which is related to data science in cyber security. And you can see vulnerability management solutions, and here you can see external cloud containers based safety and cyber security also we are doing it. And further here you can see that we are doing pen testing, and we are the CVE authority in India who give vulnerabilities for a CVE, vulnerability ID in India. Thank you. Hope if any one of you are having any questions, you can come up with.